Welcome to the second part of the session on economic order quantity and reorder point. In the last session, we have studied the concept of economic order quantity. We have studied the derivation of economic order quantity. We have studied the two major costs involved in economic order quantity, that is carrying costs and holding costs. So we have studied that EOQ is the point where carrying cost is equal to the ordering cost. So the total cost is minimum at that point. If we draw a graph between the total costs and the quantity ordered, then EOQ is a optimal point where the two curves intersect. And then we had also studied the mathematical derivation along with the mathematical numerical example. Now in this session we will be studying what are the reorder points, at what point usually we order EOQ. Then EOQ model, we are also assuming that we order the same quantity every time, that is EOQ is constant. And the time when we order can vary. So we also call this model as Q model. We will be also studying another model wherein there will be a fixed periodical review. That means the period of review of ordering will be fixed. For example, every month you want to review that what is the inventory position and you want to order. So in that case, EOQ cannot be constant because sometimes you may use more inventories, sometimes you may use less inventories. So we will be studying that model also, P model. So first of all, let us start with the basics, that is when to reorder with EOQ ordering. What is a reorder point? We say when the quantity on hand of an item drops to this amount, the item is reordered. For example, there is a point wherein you say that if my inventory drops to this point, then I will reorder it again. In your homes also many times you say that yes, you have made a mark, let's say, to your container. So when a particular sugar or a flour or some pulses drops to this level, then it's the time to reorder for more. There could be instances when you say when it becomes zero, then you will order. But sometimes you may need that item again. You cannot afford for certain things, for example, flour, for rice, for sugar. When it becomes zero, because it will take, there is a lead time also when you order and when the material arrives. So by that time you have no material with you. So similarly in industries also, there is more criticalities and there are so many items. So therefore reorder point is what is that quantity at which you want to reorder, at which you want to make a purchase order. Then further, there is a concept of safety stock. What is safety stock? Stock that is held in excess of expected demand due to variable demand rate or lead time. Then there is a concept of service level, probability that demand will not exceed supply during the lead time. So safety stock, again we can draw an analogy from our homes. So there should always be a mark on a container for whatever item you are using, that when it drops to this particular level, then it is the time to order more. Then there are certain items in industries, you can very well imagine there are certain items which it cannot be available just if you go to the near market and you can purchase them. There are some items which you have to order from another town, another city, and that item has to be manufactured. Then there could be some items which you are importing from another country. So therefore you have to maintain certain safety stock. For each material there will be different safety stocks. Some items which you can procure locally, the safety stock can be less. For some items which you have to procure from another city and which will be manufactured, the safety stock will be more. And some items which you have to import from another country, there definitely the safety stock will be much higher. So if you see from this particular slide, we have just tried to show at the bottom, it's just indicative safety stock. It is being shown. So there is a curved line, a broken line which is coming, which is showing that the material is being used, it is consumed at an uneven rate. And there is a ROP, that is horizontal line. The ROP is reorder point. So at this point you have to reorder, and below this there is a line called safety stock, because there is a lead time. When you reorder and the time when the order will be materialized or the material will come, so till that time how you will use that material. So there should be a safety stock. So there is a presumption that you will be consuming that safety stock by the time the new material arrives. So that is the concept of safety stock. So reorder quantity methods, there are various methods of reorder quantity. So we say that reorder quantity is the quantity of items to be ordered so as to continue the production without any interruption in the future, so that your machines may run or whatever items you want to sell. If it is a distribution center, you can sell those items. So some of the methods employed in the calculation of reorder quantity are also there. There is a fixed quantity system, then there is an open access bin system, then there is a two bin system. What is a fixed quantity system in reorder? In fixed quantity system, we say that the reorder quantity is a fixed one. Every time when we reorder, it's a fixed quantity. The time for order may vary. So in the basic EOQ model which we studied in our last session, we were studying the fixed quantity system. And we say when stock level drops to a reorder level, then we place a new order. So we calculate this using the EOQ formula. So we can say what is the reorder level quantity. So it is your safety stock plus your usage rate plus your lead time. So that means what is your safety stock and what is the rate at which you consume the item and what is the time. Lead time is the time from the point you order the material and the point you receive the material. That is the lead time. So there is a concept of inventory cycle. So this, if you see, these are three different kinds of, you are seeing triangles. So basically from the first left hand side, we are showing you that some quantity has been ordered. So the straight line, the vertical line shows that the quantity ordered has been received. Then the slant line, the slanting line is showing that the order, the inventory is being consumed. And then in between there is a reorder point. So the point, so you don't let the inventory to become zero to order, but you order much before the inventories become zero. So that becomes your reorder point. And then once again the item will come, new inventory will come, again it will be consumed and again. So this is a cycle. So this is called the inventory cycle. It will differ from product to product. It will differ from business to business. So therefore you can say that you order and then you have to see what is my reorder point and what is my lead time, and accordingly what kind of safety stock I should have in my business. And then in the middle you are seeing the red line is showing the average inventory, which in the EOQ derivation we assume that it is Q divided by 2, so which is the average inventory. Now in a simpler manner, to understand it simply, there is also a model called open access bin system. So to understand the reorder point, it's very easy to understand. Open access bin system, suppose there is a factory, you have a bin and that bin you can fill it with items to the maximum level. And these open bins are kept at places nearer to the production lines. So what operators will do, operators will use these items without making a record. So items are replenished at fixed timings. So for example, for less costly items, let's say for nuts and bolts, you can use this system. So whenever you see that the nuts and bolts have been depleted, you use. So the better way is to use a two bin system. There are two bins. So what you do, there are two bins are kept having items at different level. Let's say nuts and bolts. When first bin is exhausted, So it indicates it is the time to reorder. So there is a second bin, so it is like a reserve stock. So it's like your safety stock, and which is used during the lead time period. So by the time new nuts and bolts arrive, then they can be put in the first bin which has been exhausted. So by the time the new order, the new nuts and bolts come, the supervisors can use the second bin. So that is the concept of two bin system. So in a small scale industry, you can use those systems also. So this very well tells you the concept of reorder point and the safety stock concept. So what are the determinants of a reorder point? Reorder points actually depends on the rate of demand. If the demand is very high, the reorder point will come very quickly. The lead time, demand or lead time variability, stock out risk. For that you have safety stock. So therefore, if the rate of demand is low, the reorder point will come after some time. If the lead time is more, the reorder point will come early, and vice versa. So overall, if we summarize what are the EOQ model equations, so we will see it on the slide. Optimal order quantity Q is equal to under root T into D into S upon H, where D is the annual demand, S is the ordering cost, and H is the holding cost per unit. Expected number of orders N is equal to D upon Q. D is the annual demand, Q is the quantity ordered in one order or economic order quantity. Expected time between orders is equal to working days per year upon N. N is the expected number of orders. Small d, what is small d? It is the demand per day, is equal to annual demand, that is capital D divided by working days per year. ROP, that is reorder point, is equal to small d into L. Small d is demand per day multiplied by lead time in days. So these are the basic formulas which we have studied and which one has to remember while doing the numerical problems based on EOQ. Now, as we were saying that till now we were studying the Q model of EOQ. What is Q model of EOQ? Q model means that every time when you order, the quantity order is fixed, but the time of ordering may vary. So for example, when your reorder point comes to that level, that if your demand is more, the reorder point will come early. If your demand is less, the reorder point will come later. So there is no fixed time. For example, in your homes also, sometimes you go outside for 10 days for an excursion trip. So you have not used the materials in your kitchen. So as and when you see that there is some minimum level reached for your various pulses, flour, sugar, etc., then you order them. So there is no fixed time that you will order them. So that is called the Q model. But the quantity which you order, for example, it's say constant. So the same model you can apply in the businesses or industries. However, there could be a situation when your period of reviewing the inventory level is fixed. For example, let's say there is a company, Hindustan Unilever. So its representatives goes in a particular city every 15 days. So whosoever are their dealers of Hindustan Unilever, he asks them that what kind of material, how many soaps you want, how many shampoos you want, how many washing powders you want. So he will see. So depending on, in some fortnight the demand will be more, so this dealer has sold more. In some fortnight he would have sold less, but he will take the order from them. So the order quantity will vary here, but the time of ordering is the same. So that model is known as fixed period model or periodic review model, or we call that P model. So here this model tells you how much to order, because every time your economic order quantity will vary. It will not be constant because the period of ordering is the same. And here the orders are placed at fixed intervals. That fixed interval can be 15 days, it can be 1 week, it can be even 1 day in large industries. And here inventory brought up to a target amount. And the amount order will varies, but you will have a target that yes, at any point of time I must have so much quantity of this particular material A, I should have so much quantity of this material B, or this material of this quantity of material C, and so on. So there is no continuous inventory count, and there is a possibility of stock out between intervals also over here. Sometimes it happens because you are reviewing after, say, every fortnight. Sometimes it may happen that there is a stock out which has happened. And it is useful when vendors visit routinely, as I said earlier. So let us see from this slide this model of fixed period model, that is when to order. So here you have fixed the period. So on the bottom line, you are seeing the time, the x-axis showing you the time, and the y-axis is showing you the inventory level. So here you are seeing in the blue color period. So your period of reviewing the inventories is fixed. And on the top there is a horizontal line in yellow color which is showing the target maximum. So you want to, whenever you order, you want to have the inventory at this maximum target level. So at first period, you have ordered something, you have consumed it, and then once again, the vertical line shows that the order has come. Again in the second period, the slanting line which is going downward shows that you are consuming the material, and at that point you have reordered. So the reorder point is, so the inventory consumed is more. So the order you have given is also more. In the third period, the consumption is less, and so the order given is also less. So every time the quantity ordered is varying. So sometimes the quantity ordered is more, sometimes the quantity ordered is less. So this is called fixed period model or P model. Now we go to we will be talking about another very advanced model which we call as EOQ for production lots. Now what happens in a production setup? How much their economic order quantity is that how much we should produce, what will be the optimum level of production. So here we assume that this industry is manufacturing some item. Let's say it is producing P items every day, and there is a demand for those items every day which is T. So here we are assuming that the items which it is producing P is more than the demand. So there will be, so let's say it's producing say 100 items every day, and the demand is just 5 items every day. So there will be an inventory of 95 units day after day, every day. So based on the annual demand of that product, how many days it should manufacture those items until that demand is used and the inventories is replenished, or the inventories is depleted and further replenishing need to be done, then further it can start its production cycle. So here we will be studying the production cycle. So for example, we will see from this slide, EOQ for production lots, it's used to determine the order size of production lot, differs from order 1 because orders are assumed to be supplied or produced at a uniform rate which is P, rather than the order being received all at once. Because in production, any production setup cannot make all the items in one day. It has to be made over a period of time. So every day there is a capacity of any production plant. So it answers how much to order and when to order, or how much to produce. And it allows partial receipt of the material. It is suited for production environment. And here we assume that there will be lower handling cost than the basic EOQ model. Now, what are the reasons for variability in production? There are reasons of variability in production also. Sometimes there are employees, machines and suppliers produce units that do not conform to standards. There is inaccurate engineering drawings. There is production personnel try to produce before drawings. The customer demands are unknown. So there are reasons of variability in production also. Now let us see this slide of POQ model in inventory levels. Now here on this slide you are seeing this graph. The yellow color shade, the supply begins, and the second part, which is shaded by blue color, here we are showing supply ends. So basically what is happening, that this industry is producing some item up to I, that is inventory, and then the blue color is showing the demand portion of the cycle with no supply here. So once the yellow portion is showing production portion of the cycle, it has produced some item, and the blue portion is showing that it has produced those items and then those items will be sold as and when the demand comes. Now in this second slide you are being shown this two similar kinds of triangles. So in one triangle, in the yellow part it has made the production, in the blue part the horizontal line at the top is showing the target inventory levels. The blue part shows that inventory is already there, so it should stop the production over there. The second triangle is showing that it is the second cycle of the production which has started. So again in the second triangle the yellow shaded portion is showing that it is making the production, and then again the blue portion that there is a excess inventory and that inventory will be consumed. So basically in this second model we are saying this model is EOQ for production lots. So we are assuming that the supply rate P is greater than the demand rate D. The change in the maximum inventory level requires modification of the total stocking cost equation. So here the total cost or the total stocking cost is equal to Q by 2 into P minus T upon P into C. So which is the carrying cost. So here the difference is that earlier it was Q by 2 into C. Here there is another added expression, that is P minus T upon P plus D by Q into S. So the optimization results in economic order quantity is equal to under root 2ds upon C into P upon P minus T. So this equation has been derived through derivation. So here you have to remember that P is the production of units on per day basis and D is the demand on per day basis. And here another assumption which we have made is production is more than the demand. So once you remember the basic formula of EOQ, which is under root 2ds upon C, so here you have to add another expression, that is P upon P minus T, which you have to multiply with the original expression. So we will just quickly take one example of EOQ for production lots. There is a Amex company which buys a particular size of nails from Torrent company to produce furniture. Torrent company can supply nails at the rate of 3,500 kgs per day for ₹10.50 per kg. Amex company uses the nails at the rate of 800 kg per day and operates 365 days per year. So you have to calculate the economic order quantity. So basically in the next slide it's saying that Amex annual carrying cost for nails is 20% of the acquisition cost and the ordering cost is 5,000. So we have just assumed some figures over here in this question. So what you have to calculate what is the economic production lot size. So instead of saying economic order quantity, we are saying what is the economical production lot size, and B, what is the Amex maximum inventory level for nails. So just put those figures in the formula. So all these figures are given. Small d is the demand every day, which is 800 kg. Annual demand is 365 into 800, which because a year has 365 days. Small p is the production per day. Capital S is the ordering cost, which is given in the question. C, carrying cost, which is given 20% of the price, so which you can calculate 2.10 kg per annum. Just put it in the formula. So the answer which you will get is 42,455.5 kgs per order. So that means the production lot, economic production lot should be of so many kgs. And then annual stocking cost, you can again put it in the formula. That is total stocking cost is equal to carrying cost plus holding cost. So put the formula, put the values they are given, and what you get is 68,777.90. And here again you will see the carrying cost is equal to the holding, the carrying or holding cost is equal to the ordering cost, which is 34,388 rupees. And so therefore finally we will see this. To summarize, so these are the equations of EOQ model equation: optimal order quantity, you can say under root 2ds upon h, 1 minus d upon p, maximum inventory level formula is there, setup cost formula is there, d upon q into s, then holding cost formula is there. This is the second model, that is production optimal quantity, POQ model. So I hope you have got a fairly good idea of economic order quantity, reorder points. You have seen the advanced model also. So we will suggest you to refer to some textbooks also and do some numerical problems. So thank you so much.